Hi everyone, I'm Emorie Beck and I'm a postdoc at Northwestern University Feinberg School of Medicine. And today I'll be talking to you about some of my work titled Persons, Situations, and Time, Idiographic Behavior Prediction. So in psychology, one of the kind of central focuses of our research is on the study of behavior. And specifically, we're often interested in describing the behaviors that people engage in, predicting the behaviors that they do, and then finally explaining why they do those behaviors. And in the study of behavior, we've also focused a lot on the idea of persons as the initiators of these behaviors and the characteristics of persons who do behaviors, as well as the situations that may impact individuals' behaviors. Today, I want to kind of focus in on the idea of prediction of behavior, which when we look at the literature has historically been one of the most difficult and frequently studied areas of behavior. So specifically, let's imagine that we have something like procrastination, a behavior that many of us have dealt with in the past. A kind of person-oriented approach might be to look at something like the Big Five, or extroversion, agreeableness, conscientiousness, neuroticism, and openness to experience, and see if individual differences in these characteristics are associated with the frequency with which people procrastinate. An alternative approach, then a more situational kind of perspective, would be to put people into a situation and then kind of modify characteristics of that situation to see if this impacts the rate at which they procrastinate. And so we might do something like try to modify their mood. We might give them a really boring task and see if they procrastinate on it. We may give them a neutral task as a control, or we may give them a task that makes them angry, with the idea being, again, that people are going to have these kind of different rates of procrastination depending on this context or this experimental manipulation that they are placed into. But a kind of problem with a lot of these experiments and these observational research designs that we have seen is that a lot of them result in these really small effect sizes and this sort of inability to accurately predict the behaviors people engage in and when they will engage in them. And I want to argue that this is due to a couple of critical assumptions of both of these paradigms. First, that situations and experiences should have similar consequences across people. And second, that people with similar levels of a personality characteristic should behave in similar ways. So an alternative assumption that we may make, and that I frequently make in my own research, is that situations and experiences should have different consequences, not similar consequences across people, and that people with similar levels of a personality characteristic may not necessarily behave in similar ways. And so in the present study, we're going to be looking at these two different behaviors or experiences, procrastination, loneliness, and I'm going to be asking whether or not person characteristic or these psychological and kind of experiences that folks have are predictive of these, whether situations are predictive of each of these, and finally, whether timing features, time of day of the week, etc., are going to be predictive of when people experience or engage in these behaviors. And I'm going to be specifically taking this idiographic perspective in which I'm going to be focusing on a single individual at a time and seeing the degree to which I can predict both of these for that person. So I'm going to ask 5 main research questions. First, to what degree can we predict behavioral and experiential outcomes? 2, are there individual differences in how predictable those outcomes are? 3, do certain categories of features, such as persons, situations, and time, outpredict others? 4, which features play the strongest roles? So specifically, which features? And then finally, are there individual differences in which features play the strongest roles? So getting into the method, you can see the registration at the link here. So for participants were assessed in an experience sampling design 4 times a day for 14 days. At the initial sample was 199 participants who completed about 8,400 surveys, and on average at that point, it was about 40 surveys per person. The sample was relatively diverse for a US college sample with respect to race and ethnicity, and was relatively young with a mean age of 19.51, as well as relatively heavily female. Based on our pre-registration, we then removed 85 participants for having less than 40 surveys, and another 10 participants for having low outcome variance, so having either no or almost none variability in their procrastination loneliness across their training set. And then finally left was the final sample of 104 individuals who had nearly 6,000 surveys between them, and an average of 60 surveys per person, thereabouts. Again, still heavily female, quite young, and relatively diverse with respect to race and ethnic identity. For our measures, we had personality and affect measures. So we had the full BFI2, which was administered with 75% planned missingness, as well as a subset of the PANAS-X with redundant items with the BFI2 removed. And these were answered on a 5-point Likert-like scale from strongly disagree to strongly agree. Second, we had 2 types of situation characteristics and experiences. First, we had binary indicators generated by undergraduate research assistants, where 0 equals no and 1 equals yes. And then second, we had the ultra brief diamond scale that was answered on a 3-point scale from 1 not at all to 3 totally. Finally, we had a number of timing features which were engineered from our timestamps. This included time of day, morning, midday, evening, night, day of the week, whether it was Monday, no or yes, and finally linear, quadratic, and cubic trends, as well as 1 and 2 period cosine functions. And then finally, our outcome measures were these procrastination and loneliness binary indicators, where 1 equals yes, 0 equals no, and these were lead 1, basically such that they were staggered so that current time point, personality, affect, situational, and time, we're predicting next time point outcomes. Our analytic plan was 3 machine learning classification models. So we used elastic net regression. We tuned the lambda penalty parameter as well as the mixture, and we had 10 values for each of those. We also used Biscuit, which is the best item scale that is correlation weighted and something I can't remember. What we were tuning here is just the number of items used in the scale. And finally, we used random forest, where we were tuning basically the number of predictors that were sampled, as well as the number of splits that could be achieved based on the sample size remaining. And for each of these, we use what's called rolling forecast validation, which is more robust to these kind of time series data where preserving the order is important. And a third of the data was used for the initial set, 5 as the validation set. Skip was set to 1, which basically means we skip over 1 observation, which basically results in about 10 to 15 rolling origin folds, which sort of approximates the kind of standard 10-fold cross-classification. And our 2 kind of assessment procedures was classification accuracy, as well as area under the receiver operating curve, or AUC. Now, getting into the results, I can't get into all of these today, so I highly recommend that you check out the Shiny app that I made that shows all of the results, specifically some of these participant level results, as well as the accuracy and the AUC for individual participants and individual models. I'm just going to go through each of the 5 questions that I posed previously and show you some data that answers some of them. So first of all, to what degree can we predict behavioral and experiential outcomes? So what I'm going to show you is distributions of AUC and accuracy across all the participants for each of the 3 models, the elastic net, Biscuit, and random forest. And I'm also going to show you then some means and standard deviations of that. So you can see that for procrastination, accuracy was quite high with a median above 0.8 and near 0.9 for all 3 models. Similarly, we see that for the AUC was a little bit lower with medians in the 0.7 range, but still, again, quite good. And we saw very, very similar kind of patterns for loneliness with perhaps just a higher degree of accuracy overall. As you can see from these distributions here, there's a little bit tighter kind of variance on the loneliness. But again, the kind of takeaway from a lot of this is that on the whole, we were quite accurately able to predict people's procrastination loneliness, although there were individual differences in the degree to which we could do that. Which leads us to our second question of, are there these individual differences and how predictable these outcomes are? And so just to kind of demonstrate that, what I'm going to show you is just a sample of participants, the same sample across each of the 3 models for both of the outcomes that just kind of shows you that in these different feature sets that we used, which were the psychological feature set, the situational feature set, and the timing feature set, as well as combinations of those, did it matter which features that we kind of used? And what we see is that there are both these kind of like cross-individual differences in the prediction accuracy in the sample, but also at the level of these individuals, we see that the individuals varied depending on which feature sets were used. And we see that these are relatively similar across each of these different models with a sort of rank order preservation in each of them. And we see a similar pattern for loneliness, where again, we have this kind of rank order preservation across the 3 different models and some variability, but that variability in terms of which features were highly predictable of the outcomes varied across people as well. So then we asked if certain categories of features outpredicted others. And so what we're going to show you here are a series of sequence plots that are going to show you kind of the percentage of the features in the final model that were retained are going to be timing features, situational features, and psychological features for each of the models and each of the outcomes. So here you can see that for elastic net, biscuit and random forest, there was some variability in the percentage of situational and psychological features that individuals had, with most people having a mix of psychological and situational features, but some having wholly psychological sets be their best models, and some having wholly situational sets be their best models. And we see a very similar pattern for loneliness as well. And again, one thing to note here is that for these random forest models, we do see that situational features seem to have performed a little bit better than the other two models. What about which features play the strongest role? Well, here's where I'm finally going to show you the full list of features, and I recognize that they might be a little bit difficult to see, so feel free to pause and check those out if you are able to. In terms of which features play the strongest role, basically each of those has a number, and they're going to be around this circle, and then I'm going to show you kind of a series of proportions of individuals who had those features in their top 5 best features. And so first of all, you can see here that timing features were almost not present in the elastic net models for procrastination, but the energy levels seemed to be a good predictor. We saw a similar pattern for the biscuit models, but then we see some differences for the random forest models, where specifically we see that the situations start performing very well in terms of being strong predictors. And for example, here we see that internet use and sociality were both strong predictors in the random forest models of procrastination. For loneliness, we see somewhat similar patterns. Again, not a lot of timing features playing a role here, but situational features kind of vary across models. And we see that positivity and negativity perceptions of situations were highly predictive of how lonely people felt. But we also see that something like intellectual curiosity in the elastic net was also predictive of how lonely people felt. Finally, are there individual differences in which features play the strongest role? So what I'm going to kind of just show you here is basically the profile of participants' coefficients from -1 essentially to 1, with blue being negative and red being positive, and all the features going down the y-axis, and the x-axis is going to be a bunch of different participants, and then those kind of facets are going to just be the kind of categories of features. And so what I want you to see here is just lots of variability in which psychological features were there and the direction of those associations. Similar for situations, variability in which ones were in people's models as well as the direction. And finally, for time, much less present, but again, these individual differences in the strength and direction of these associations. To kind of show you that a little bit differently, what I can show you are these kind of circle graphs for 3 different participants of their biscuit models. One participant who had their best model have just psychological features, one who had their best model have just situational features, and one who had a mix of both. And what we can see here is that there are these kind of individual differences in the profile of these, with some features being stronger in some models than others, and some not being selected at all. And so again, the goal here is just to show that which features are important and the degree to which they're important very strongly across different people. And so with that, I am out of time and even over a little bit of time. So I want to thank my co-author on this project, Josh Jackson, as well as the helpful comments and suggestions from my postdoc advisors, Dan Rochek and Eileen Graham, as well as the other postdocs in my lab who all provided helpful feedback, Ellen Wilroth, Olivia Atherton, and Jing Luo. If you all have questions, feel free to either message or tweet at me on Twitter or send me an email. Preprint, GitHub, Shiny app, pre-registration, and the OSF repository are all linked here. Thank you.